Good morning, good morning. Let me know who's here in the chat, if you guys don't mind. Good morning, Liberty. Thank you. Good morning, Hunter. Hope you guys are doing good. What up, Rachel? All right, so I'm guessing it's you three. No, it says I have four, so maybe there's one more. But so guys, I wanted to start off by first of all, I don't know how homework went yesterday. It looked like you guys had a pretty good handle. So before we get going on the lesson today, I wanted to talk about the homework. So if you guys have any questions from the Khan Academy, go ahead in the chat. Just let me know yes or no from the Euler's method. Nope. Okay. Don't think so. All right. Thank you, Hunter. So we'll get some more practice with the Euler's method and the assignments today and tomorrow. So we will see that. Okay, so first thing I want to talk about, the College Board, I guess actually it's AP, came out with a YouTube page. I know I mentioned it to you guys, but they officially launched it yesterday. So if you guys go to YouTube and look up like AP, I forget what the exact link is. You probably just search AP math or something like that, and it'll pop up. But they have videos up there now. I think the BC videos were for Unit 9, which is something we've already done. But it's a good refresher, even though Unit 9 is not going to be on the AP test. It is a good refresher. They might have other resources from like Calculus AB that might be a good review to look over. So just so you guys know, there's a resource for you. It's up and running. The second thing I wanted to tell you guys is I think that the schedule is going to change a little bit next week. So today we're still going to do like our normal thing that the calendar says. Tomorrow you guys will be off completely. But starting next week, my streams look like they're going to be minimized. So just from I guess everyone, when we came together and we had like our staff meeting and everything, I guess a consensus was kind of made to limit assignments and limit, I guess, teachers using students' time, I guess, almost. I don't know how to exactly word it, but yeah, so math is going to be Monday and Wednesday, and then other subjects will be other days. So to be honest, I didn't really look at what the other subjects were, what days those were, but it sounds like the they want us to be doing just math only on Mondays, Wednesdays, and yeah, I think I'm gonna like in terms of like the format of what we're doing, it's not gonna change. So it's not gonna impact us directly. It'll just mean a little bit less guidance from me. Um, I mean, for you guys, I'm not really worried about. Uh, you can still always reach me, and like if you need some help with something. But just so you guys know, I think things are gonna be like, I guess, a little bit easier, a little less time consuming. Even though I don't think what this class is very time consuming as is, because we spend basically this hour, and you guys get most of your assignment done anyways. So I'm just gonna do what I'm told to do. So I'll be updating it more. You'll see the calendar for next week. I don't even know all the details yet. I just got an email and I tried to decipher it how I could. So I'll figure it out more. But I just wanted to prepare you guys, not just for this class, but for all your classes. It sounds like that's going to kind of be implemented, which means, just so you know, we won't be doing this. We'll probably only be doing this 2 times, really. Really, it'll probably end up being 3 times. 3 times a week. So Monday, Wednesday, Friday. Friday's used as like a review day. It's a review day. I'm not supposed to give any new assignments. It's just supposed to be a day where we can review topics over the week that the week we discussed. Obviously, like I said, with this class, it's a little different. So I don't know. I just want to let you guys know now. So if you see something drastic changing next week, that's why. Okay, so if you have any questions regarding that, please ask. I don't know. I like how everything's set up, but if that's what I gotta do, it's what I gotta do. So no big deal. Today, what you guys will be doing is your Unit 7. So today's Unit 7, progress check, Part A. So multiple choice question, Part A. So I signed that to you guys a couple minutes ago, so you guys can get started on that. It's going to be all about differential equations. Euler's method is on there. Writing differential equations. So if you guys have any questions, obviously, as you go, just type them in the chat and we can discuss. So go ahead and get started. Good morning, Jaden. Jaden, what are you doing this morning up so early? I get up at 6:45 or 7 every day. So you want to learn some Calculus BC this morning? I'm an early riser, always have been. Jane, you are quite different. I am not an early riser whatsoever. I love my sleep. Can you go over number 4? Yeah, no problem, Hunter. All right. All right, number 4. All right, which of the following is a solution to the differential equation x y prime minus 2y equals 2? Okay, so couple ways you can approach this problem. Big thing we want to look for is all those options, A through D, Hunter. We want to say, okay, if I plug one of those into the equation that we're given, and I take the derivative of one of those, and I end up solving or simplifying that down, and I get one side is equal to the other side, then I know it's a solution. So your game plan of what you want to do is probably just try each of these options and see where it takes you. So for example, let's just try A. So we try A. All right, A says y equals x squared minus 2, which means y prime is equal to 2x. Okay, if we plug these back into the differential equation that was given to us, we get x times 2x minus 2 times x squared minus 2 is equal to 2, which means 2x squared minus 2x squared plus 4 equals 2, which means 4 equals 2. So you want to ask yourself, is that true? Obviously no. 4 does not equal 2. All right, so A can't work. And you're going to do that for each one of these problems. Okay, so you're going to try B, you're going to try C, and then you're going to try D, and then find which one works. So I'm going to stop there, Hunter. Let me know if you want me to keep trying other ones or you want to go over some more, but that's the process you want to take for each of them. Got it? Okay, cool. Okay, Liberty said, do we have to solve for fx in number 10 before we can do the Euler's method? All right, let me see number 10 real quick. No, Liberty. So that form, the equation you want to use for Euler's method, you always want to use the derivative equation. So the derivative equation is going to give you f of x sub k, y sub k. So the differential equation they use is the one we want to use to actually solve that value. So you're actually in good shape with that one. You can just go right into Euler's method. And again, the reason being for that is because we want to take slopes of tangent lines that are getting closer and closer together to approximate values. And when we find slopes of tangent lines, that's given to us by the derivative. So we definitely want an equation that represents the derivative. Okay, on number 12, if you're going from 1.5 from 0, you just have to make your delta x be negative 0.5. Yeah, exactly. You got it, Rachel. When everyone's done, when you three are done, if you guys want me to go over the answers, let me know. Okay, I'm gonna get some Rachel. I'm gonna see what the other two are at, and then we can go from there. It sounds like Liberty's pretty close to being done, at least. Okay, just let me know, guys, when you guys are done with 12, and I'll go over it. Okay, thank you, Liberty. Once Hunter says he's done, we'll go through them. All right, Hunter's done. Cool. All right, guys, go to number 1. We'll start there. Okay, make notes of anything that you missed and anything you'd like to go over further. We've got about 15 more minutes. All right, so number 1, you should have gotten C. Number 1 was C. Number 2 was D. Number 3, oh, hold on. Number 3, I just circled the answer. I don't know what letter it was. Number 3 was C. Put that down. Number 4 was C. Number 5 was D. Number 6 was B. Number 7 is B. Number 8 is D. Number 9 is B. Number 10 is D. Number 11 is B. And number 12 is A. So any of you guys need me to repeat or would like to go over, let me know. Whoop, whoop. There you go, Rachel. All right. All good. Cool. All right, guys, that's all we got for today. So you guys are good to go. Tomorrow you're off, so this will be the last time I see you for the week. So Monday we'll definitely have a stream, and then I'll get to fill you guys in more of what the plan is moving forward. So keep an eye out over the weekend for that schedule. Other than that, you guys are good to go. I hope you have a great weekend. As always, let me know if you need anything. Thank you. I will, Rachel. You too. Thank you, Liberty.
take your stories to hell. I've got nothing left to give. I know it's happening again. You opened up your heart and let somebody in. Now you've got a stranger in your home. You could kick him out, but then you would be alone. Turn back the clock, see the time we lost, make a different choice, and watch the whole picture change. Learn that to hear is to have a voice. We could have it all if we just get out of the way. How can you move forward when you don't even know where you've been? Hopelessness has done nothing for me. I want this thing to live. Here we are, it's happening again. Opened up your heart and let somebody in. Now you've got a stranger in your home. Might as well sit down and try to get to know him.
Is this song called Song for Zulu? Some say love is a burning thing, and that it makes a fire. But I know love as a fading thing, just as fickle as a feather in a stream. See, honey, I saw love. You see, it came to me. It put its face up to my face, so I could see. And then I saw love. It disfigured me into something I am not. See the Cajun call. I said, come on in. I will not open myself up this way. And lay my face to the soil. And gnaw my teeth to the sand. I will not lay like this for days now. You will not see me fall, nor see me struggle to stand. To be acknowledged by some touch from his gnawed hand. You see the Cajun call. And I said, come on. I will not open myself up this way. See the moon is bright in that treetop night. I see the shadows that we cast in the cool moonlight. Then my feet are cold, and my heart is white, and we race out on the desert plains. See, honey, I am not some broken thing. I do not lay here in the dark waiting for me. My heart is cold, and my feet are light, and we race out on the desert plains all night.
All right. Hello, everyone. Maybe get my face up. Calc AB. How's everyone doing? If you guys don't mind, just typing something in the chat so I know you are here. Good morning, good morning. Hello, hello, hello. Good morning. All right. Almost done with the week, people. Doing pretty good. I think it's supposed to be a pretty nice day out today, so if you guys get a chance, go outside. Enjoy it. Obviously 6 feet apart from people, but nonetheless. All right. Morning, Braden. I'm going to give it a couple minutes, let some people flow in. If you guys, go ahead, hit that like while you're waiting. You got nothing better to do. Good morning, Alexis. So, guys, first things first, we're going to start with talking about the Khan Academy. So, if you have any questions from the Khan Academy, go ahead and get that open. We're going to start there. And if you do have any questions, go ahead and put them in the chat. Just try to be specific as you can with what it's asking, or maybe at least summarize the type of question it's asking that you want to go over, and I can try to find it. Okay. I'm not seeing anything for the Khan Academy, which is okay. So if you guys don't have any questions, that's fine with me. If you think that you do have questions and you forgot to ask or whatever, I'm always available. So just email me or my office hour. You can stop in. So let's get started for today. First thing I want to talk about is just in general what's going to be happening kind of in calculus in general from here until X amount of time, because like obviously none of us know how long we'll be out for or whatever. So we got together. I talked about this before. We got together as like a staff and discussed kind of what's going on and everything and our ideas. A consensus was kind of made, and it seems like it wants to stick with where we're going to separate days a little bit more so, meaning like math Monday, Wednesday, everything else Tuesday, Thursday, basically. So like the idea is that like the math teachers would only be teaching Monday and Wednesday, and then Friday would be like a review day. So we're not going to actually do that in this class. AP works a little bit differently. So I talked to Mr. Snook, and most of you guys are in his stats class, or at least a lot of you guys are in his stats class. So, actually, I don't know, maybe not so much you guys. I know BC all is in there, but at least some of you are in his stats class, so you guys will hear probably from him too. But with AP, we still have to get you guys ready for this exam, and at least until I don't know anything enough about what the exam's going to entail. They still have to give us some more information by April 3rd. So I got to move ahead as if they were going to give you a normal exam where you have like half multiple choice, half free response, 45 questions, multiple choice, 6 questions or whatever, free response. So I have to keep that mindset, meaning you guys are in a little bit different boat. You guys are the AP students. You're supposed to we're supposed to be getting you guys prepared for that. That's our job, and I know it means a lot to you guys. So I think the way I organize it anyways, I don't feel like I'm overworking you guys. I don't feel like I'm being unfair with assignments, and I don't think it's like causing you too much stress, in my personal opinion. That's my opinion on the matter. You guys might want to give your input. I'll be happy to hear it. But so I just saw the chat. Brayden, is that why I have a snow day in English? Yeah, Brayden, that's probably exactly why you have a snow day in English. Okay, it's supposed to start Monday. It's supposed to be implemented Monday, but I'm sure some teachers are implementing today. I don't know. I give you guys a schedule for the week, so we're sticking to the schedule for the week. So Monday we'll figure out what's going on from there. But isn't the new AP all FRQ questions? Stacklin, that's what it sounds like, but I don't know. A lot of people are interpreting as that's what it meant. I interpret it a little bit differently. It doesn't make any sense for that to be the case. But if I do find out that's the case, we're going to be shifting our focus a little bit in this class. We are going to be doing heavy FRQs for the rest of the year, if that's the case. So once AP actually releases exactly on that website, that they have like an entire column dedicated to like what type of questions will be on each individual exam. Right now, Calculus AB is left blank. So they said they'll get it up by April 3rd. So once I have that information, Stacklin, I will let you know. Jasmine, do the other teachers know that we're continuing how we have been? That's a good question, Jasmine. I think AP is all in the same kind of boat. Math's different though, and I think you guys understand that. Math's a lot different than English is, or history is, or government is. I mean, it's a lot different. Math is a subject that you're not memorizing things. Okay, first of all, you have to do work. You have to do practice problems, and in order to know how you're doing, you need feedback. So I think that it's a little bit of a different beast, but I think other AP teachers all agree. I mean, we all have a job to get you guys ready for this. You'll probably hear more by the end of the week from your other AP teachers. I'm sure everyone, just like me, is scrambling, trying to think like, oh, what does this mean? What do we have to do? Blah, blah, blah. But at the end of the day, like, we have to get you guys prepared for this. And I know, like, me personally, I'm not done with all the content. So I can't just stop here and just, like, say, okay, guys, we'll just do what we know. I mean, I have to teach you. Like, at the end of the day, I have to get you everything you need to know. So I don't have a choice. I think Mr. Snook, who, if you have him, agrees. He said he agrees he has no choice. There's really nothing us AP teachers can do about it. We have to keep going. And in order to do that, my goal is I want to get you done with all the content as quick as possible, because that'll give you more time so we can actually prepare for this exam. How we're going to prepare, again, like Stackland mentioned, it's all going to be dependent on what kind of questions we're going to see. But moral of the story is, I'm just saying I don't want to. I think personally the way that AP is going right now, I kind of like our flow, our system. Now, I don't know about timing. I don't know, like, I would like to probably keep our streams to like 10 to 11 every day to keep that rhythm going. I don't know if I'm going to have to change that or if I'm going to have to adjust it, make it longer, shorter. The nice thing is that we're going to get to a point, guys. So, like, at least for next week, I still have stuff to teach you. So next week for sure, I plan on doing my full schedule. So, like, my goal is before spring break, which, by the way, starts next week. My goal for you guys is I want to get through all of calculus. So I want to have everything done before we get through spring break, which I think is pretty reasonable, actually. Yeah, I think it should be decently reasonable. If I'm doing the math in my head, I think we can get it done. Which means over spring break, to be honest with you guys, and I told you this before, I'm going to give you an assignment. So I'll give you something to do. It'll be a review. I just think that it's going to be beneficial. Plus, you guys have a whole week off anyways. I can't imagine any other teachers are giving you assignments, and if they are, they're probably AP teachers too. It's not going to be something crazy, just something to keep you guys, keep us on this momentum, keep you working and sticking with the AP stuff, and nothing's being lost. So just expect that. What it's going to be, no clue yet. Again, hopefully, what's today? 26th, so 30th is Monday. They said by April 5th. Is that the date I keep giving you? AP said February, March, April. I think I said April 5th. So by next Friday. No. Next week sometime. We're supposed to be getting feedback on what's going on. Maybe it was April 3rd. I can't remember. But regardless, we're getting whenever I get that feedback, it's going to change, like I said, what I do. April 3rd. Okay, that's what I thought. So by next Friday, I think that's what April 3rd is. Hopefully it's Thursday. That'd be ideal. Let me pull up my calendar. Yeah, next Friday. Okay, so by next Friday I should know, and that's gonna give me more information on what kind of assignment I want to give you over spring break. And then after spring break, that's when things might change a little bit. So what we'll probably do after spring break is I'll probably go to like a Monday, Wednesday, Friday stream situation, and I'll give Monday I'll give an assignment, because at that point I won't be teaching you guys anything new. Like after spring break, the goal is like there'll be nothing new coming out of my mouth, new information. Everything will just be review. So my plan is just Monday, Wednesday, Friday, give you guys an assignment, maybe 1 or 2 assignments a week, which will mostly be practice FRQs, practice multiple choice questions, just depending on what AP is going to make us do for the test. That'll be like I'll give those like on a Monday, a Wednesday, and then we'll take like those 2 assignments will be due by Friday, and then like Monday, Wednesday, Friday will all be days where you guys can come in and I can just answer questions. Okay, that's the intention. That would be the plan going forward. So I'll probably make this adjustment after spring break, just because I can at that point, and we can as a class, because it'll make more sense. Next week though, I'm gonna want to stick to how things are going. Okay. So I just want to, like I've been saying, I want to keep transparent. I want to keep you guys in the loop, let you know what I'm thinking. If you have concerns about other other AP classes, I'm sure your teacher will address it at least by Monday. We're supposed to have a meeting Monday, so we'll definitely get more information. But I got to imagine a lot of the AP teachers are scrambling a little bit with this, so they'll probably email you or you guys can reach out. So figured I would address that. Ease your minds a little bit. You guys should be excited. Like I said, 1 more week and you're done with AP calculus pretty much. Another big idea, and I think the assumption, if you guys couldn't tell, is really that we're not going to come back to school. I think that's the assumption everyone's making. Hopefully that's not the case, but I guess the vibe everyone's kind of giving off, and just the way things are going, that's what it seems like. Hope it's not true, but if that assumption is true, you guys we'll figure out what day the AP is given, because again, they haven't released that yet. But once all that information is given to us, I don't know what's going to happen after you're done taking the AP test. I don't know if you guys might be done with the school year. No clue what we're going to do with that. So that's a whole nother can of worms we're going to have to deal with when time comes. But just so you guys know, I'm gonna be as transparent as I can. I'm gonna keep you guys updated, give you as much information as I can. So hopefully, if you guys know too, if any of your friends in class aren't showing up to the stream or aren't watching the videos or whatever, and don't get this information, please feel free to email them or text them so that they know, because I know a lot of people haven't been attending, and I don't know who watches my YouTube videos and how carefully they watch it. So important announcements like this, I'll have to write out, but just so you guys know, feel free to keep anyone else in the loop that you might think of that doesn't watch these. So, okay, I think that's everything I want to get through with that. I think we are good to start with today's lesson. So what we've been doing is obviously differential equations was the big theme. That's the big unit. We started off on Monday, and Tuesday and Wednesday. Really, the three topics or two topics really we talked about was creating differential equations. So like, what were they? How can we create them given situations, given like word problems? And then we talked about how we can verify solutions. So like, given the fact that this is a solution to a differential equation, how can we prove that's true, that it is in fact a solution? Okay, so those are two things kind of as our introduction to differential equations. We will be getting into today. I'm skipping over slope fields for now. We're gonna get to that next week. So slope fields is going to be a geometric approach. So it'll be like a geometric approach to solving differential equations. At the very least, even if you're not solving, we can at least estimate with them. Something BC does is called Euler's method. We're not going to do it. That's a BC only topic. That's a way to approximate it. Solutions though. But today we're going to do like a symbolic kind of point of view using algebra. And using algebra to solve differential equations, given initial conditions and given no initial condition. So just like a general solution. Okay, so you guys can see on my notebook, this is today's unit 10.3, Separable Equations. I'm going to type the page in chat in your book. It's going to be on page 616. So get your books out, get your notes out. I'll give it a couple minutes and then we'll get started. Okay. So let me show you my book here. So this is where we're at right here. All right, I'm gonna read a little bit just to give us a little background. So the first sentence, I've already talked about this. We haven't looked at Euler's method because you don't have to learn it, and we haven't looked at slope fields yet because we're gonna get to that later. So what about the symbolic point of view? It would be nice to have an explicit formula for a solution of a differential equation. That's kind of what we're looking at, to have an explicit formula. So I know my screen, hopefully you can see. Unfortunately, that is not always possible, but in this section, we examine a certain type of differential equation that can be solved explicitly. So like I said before, solving differential equations, there isn't always one method to do it for all of them. They vary quite a bit in the types that you'll see, right? Because you can imagine how many different combinations of derivatives and functions and, combinations of linear and quadratic and trig and all this stuff that can be combined in these equations. So they're not always very easy or very straightforward to solve for. But we do have one method and one way to do that. It's called a separable equation. So I want you guys to copy that definition down. A separable equation is a first-order differential equation in which the expression for dy dx can be factored as a function of x times a function of y. So I want you guys to write that down. Again, the definition in your book right there. Separable equation is a first-order differential equation which the expression for dy dx can be factored as a function of x times a function of y. And in other words, it can be written into this form. Dy dx equals g of x times f of y. Okay, hopefully you had time to copy that down. So it says the name separable comes from the fact that the expression on the right side can be separated into a function of x and a function of y. So you guys can see that's kind of what we're looking for. We're looking for a function of x and a function of y. And they get a little bit confusing from here. And I don't need you guys to copy any of this down. Just the way it's kind of worded, I think they overcomplicate it a little bit. But obviously it's the correct definition. So I'll try to walk through exactly what's going on here. So basically you have, they rewrote g of x f of y as g of x divided by h of y, where h of y is 1 over f of y. So they just rewrote f of y as another expression, they just called it h of y, just so they can make this fraction. Okay, so they can make it as dy over dx equals gx over h of y. And here's why, because they want to cross multiply and separate the functions. So they want to separate the y's from the x's. That's the big idea for separable equations. You want to separate the y's and the x's, or the u's and the v's, or the w's and the x's, whatever variables are being used. You want to separate them. That's the goal. Okay, notice what they did is when they separated them, not only did they separate the functions, they also separated the derivative. So they split up the derivative. Instead of dy with respect to x, they just kept dy on one side and dx on the other. So the function h of y with respect to y, function g of x with respect to x. So all y's are on one side of the equation, all x's are on the other side. That's the goal of separable equations. Simply put, that's the goal. Then we integrate both sides of the equation. So remember, our goal ultimately was to get back to our original function. So we're looking to find, in this case, y. We're just looking to solve for y. Because we're given what the derivative of y is, we want to solve for y. Right? So we need to take an integral. Basically what you're having is you have derivatives on either side now, because you have dy and you have dx. So to get rid of those, we want to integrate. So that's why they integrate both sides of the equation. Equation 2 defines y implicitly as a function of x. In some cases, we may be able to solve for y in terms of x. Okay, now that's, you guys remember implicit differentiation. So it's just saying that y is a function of x. So when we actually take a derivative or we take an integral, we have to remember that it's a function of x. So we'll always have to multiply by that derivative. Okay, and they use a chain rule to justify this procedure. I'm not super concerned of what's going on here. okay, and how they did this. This is just kind of their proof of how you can do that and get back to equation 1. Okay. So this is the background of separable equations. So we want to look at how can we actually apply this to an actual example. All right, so let's look at example 1. Okay, so for the first part of 1 is we want to solve. So this is example 1 of page 617. On page 617, if you guys are interested. So it says the derivative of y is equal to x squared divided by y squared. All right. Now, what we want to do is we want to separate variables. Think of this as you're multiplying variables. So almost treat dx and dy as a variable. So if I want to get y's on the same side, I would multiply this side by y squared. So I would get y squared dy dx equals x squared. Okay, and I want to get this dx over on the right side, so I would multiply by dx. So I'd get y squared dy equals x squared dx. And that's what we call separating variables. So again, treat dy and dx as if they were like another variable, or like as if they were a value. Even though I know they're not, they're just ways to make a notation, but it helps organize your work. So another way you can look at it is think about cross multiplying. It's like I cross multiplied each side of the equation. Okay, and the goal is to get rid of dy dx. Like I said, that's not a variable. We can treat it like one, but it's not a variable. We want to get rid of dy dx. We want to ultimately solve for just y, our original function. We're given the derivative. We want to get back to the original function. So we would have to integrate both sides of the equation. All right, so this is what we get then. All right, if I'm taking the integral of y squared with respect to y, I'm going to get 1/3 y cubed plus c make sure this is zoomed in, okay? And same thing on the right side, I'm going to get 1/3 x cubed plus c. Now, big thing I want to point out are these c's. So remember what c is representing. C is just an arbitrary constant. So c is just a value. We don't know what it is though, and these aren't the same c. So really the appropriate notation would be like c1 and c2, because those aren't guaranteed to be the same value, right? So we kind of treat it as c1, c2. Now this is where it gets a little bit trippy, and I don't want to confuse you guys. I'm just going to show you kind of where it comes from, and then we can just do a shortcut from here on out. So the idea is this, all right? We want this c, we were solving for y, okay? That's the goal. Right when we get to this point, I want to solve my differential equation. That means solve for y. Okay, if I take a constant, let's say it's 7, and I have 5 over here, to solve for that, I would take 7 minus 5, right? So basically, for all these problems, I'm just going to get another constant. Whenever I do this subtraction, I'll always just end up with another constant. I don't know what that constant is, but I'll always end up with one. So what we do is we let c equal c2 minus c1. You don't have to write that every problem. You can just put a c on the right side of the equation. That's all you got to do. I'm just doing this now just to show you where we're getting this from. So again, if we have two constants and we have to combine them, they end up just being one single constant anyways. So what we have here then is 1/3 y cubed equals 1/3 x cubed plus c. So at the end of the day, that's all you're doing. The right side of the equation, you're just adding a c. Okay, now we just use algebra and we solve for y. So I multiply everything by 3. So 1/3 x cubed times 3 is just x cubed. C times 3 is 3c. 1/3 y cubed times 3 is y cubed. And then you take the cubed root, making sure that that c, that 3c, stays underneath the square root. And we're going to leave the solution like this. The book says maybe you could replace 3c with like some other constant, but that's more work that needs to be done. It doesn't matter because we don't know what the constant is anyway, so there's no point in rewriting it. All right, that's solving the differential equation. That's the work you do to solve. Okay, part B is going to be then doing our, so we're looking at these differential equations. We can solve a general solution and we can get a specific solution. So solve an initial value problem is what we call it. So given a specific situation, can we solve a differential equation? So we did all the hard work. Now all we have to do, and what we're missing, is that 3c. So what we want to do is we want to put in x equals 0 into the general solution that we found. All right, so this is our general solution we found. So what we're looking for is 2 equals 3 times the square root of x is 0. So 0 plus 3c. So I'm doing this because I need to find c. That's what I'm ultimately solving for. And that'll give me a solution to the initial value problem. All right, working from here, if I'm going to get rid of a cubed root, right, I need to cube both sides. I need to cube both sides of the equation. So I'm going to get 8 equals 3c, which means 8/3 equals c. Okay, and to actually get my solution to the initial value problem, I'm going to take the general solution I got and replace c. So I'm going to get y equals the cubed root of x cubed plus 3 times 8/3, which means y equals the cubed root of x cubed plus 8. And that's your final answer. So that's the solution that satisfies the initial condition of y of 0 equals 2. All right, so I know that was a lot kind of thrown at you. Let me hear in the chat what you guys think, how you feel about it, any questions you had on that problem. Andrew says good, thank you. Okay, good, good, good. Okay, no one else got any comments? Good, Stacklin, thank you. All right. Well, we're gonna see a couple more examples. So if you're still kind of like, let's see a couple more, and maybe this will help out a little bit. So that was an example where we could actually solve for y. So we actually get an equation in terms of y. And we did a general solution, and then we also did a specific initial value solution. So we kind of got a lot covered in that problem. Let's look at a problem that we can do the same process with, but we can't actually simplify. All right, so this is example 2, where you have dy dx is equal to 6x squared divided by 2y plus cosine y. Okay, no initial value. That's it. That's what's given to us. Okay, I know this is in your book, but I want you guys to just do the first part of this. So I want you guys to get the variables together on one side or on either side of the equation, and then try integrating. And then just stop after you get the integration. So I know the book has the solution to this, but try your best not to look. Try to do this one on your own. Do the exact same process. Get y's on one side, x's on the other, and integrate. And then just give me something in the chat when you're good. Thank you, Aber. Okay, cool. So looking at this first part, and this step is crucial. So this is like got to be something that we identify. So we're solving this. First of all, we can identify it's a differential equation, right? Because it's a derivative equal to two different variables. That's kind of like your hint, all right? Because it's not going to say, this problem it does say solve the differential equation. In case it doesn't say solve the differential equation, just look at it and you can tell that's what we're doing. First step is to get y's on one side of the equation by cross multiplying, and x's on the other. So 2y plus cosine y dy equals 6x squared dx. Okay, next step is we want to integrate both sides. The antiderivative of 2y is going to be y squared. The antiderivative of cosine is positive sine. The integral of 6x squared is going to be 2x cubed. And then remember, we got to add that plus c. Always got to add that plus c. Okay, and like I said before, ideally, if we're solving, okay, we want to solve for y. As you guys can see, there's nothing I can do to solve for y here. All right, I have a y squared plus sine y. I can't simplify that. I can't factor out a y. I can't divide by anything. Like, I'm stuck. So if you guys ever run into this situation where you can't go any further, that's okay. You're not always going to be able to solve for y. And that's kind of what I started off the lesson by saying. Differential equations aren't always perfect. They vary drastically from problem to problem. So some problems are very easy, straightforward, like the one we did before, where you can actually get to an answer. This is an example of a problem where we're stuck from there. That's the best we can do to express our function y. So this is our general implicit solution. All right, so if you ever get an assignment, now your answer is going to be completely dependent on your multiple choice question that's given to you. Well, if it is multiple choice. If it's free response, then you have to make a decision. But if it's a multiple choice question, you have to look at the answers. Are the answers simplified? Are the answers a general implicit form? Like what do they look like? So you guys have to use your brains a little bit to kind of observe what a problem is asking and looking for. Now, if it's a free response question, a lot of times they might just say, give me the general solution implicitly, which means you don't have to solve for y. Or they might state specifically, find or solve the differential equation, isolate y, or something like that. So just be careful with that, but I wanted to show you that you don't always have to be able to get y by itself from here. Okay, let's look at another example. All right, so this is the other example. We want to solve this equation. Looks pretty harmless, but there is one difference between this one and the first two we did, and that's that there's no fraction. Right, there's no fraction. We have x squared times y, not x squared divided by y. Again, and this is why it's really important you guys think of these as just, like normal algebraic variables. So just imagine this as a normal fraction equals x squared times y. We still want to do the exact same thing, except the only difference now is I can't multiply by y to get y to the other side. What do I have to do? Well, I have to divide by y. So on the left side, I'm going to get dy divided by y is equal to x squared times dx. I know I'm saying multiply, divide, but again, these dx and dy's aren't like numbers, they're not variables, they're just kind of directions. However, you really want to try to look at them as variables with separable equations. It's going to make your lives a lot easier if you just treat them as if they were variables. Okay, so again, instead of multiplying, I just divided by each side by y to get dy over y equals x squared dx. I can see my x's are on one side, my y's are on the other. Now I integrate both sides. And what's really nice about this problem is the integral of 1 over y is just natural log of y. So those should be absolute values. Okay, and the integral of x squared is 1/3 x cubed, and then plus c. Again, isolate variables on either side. Take the integral of 1 over y is natural log of y. The integral of x squared is 1/3 x cubed plus c. Now this is one of, I don't know how to phrase this, but this is like people's favorite problem to do with differential equations. This is like an extremely popular question, and it comes up often. And here's the reason why. It's because solving for y has like a little twist to it, I guess. So if I were to solve for y, I can actually do it here. All right, I want to get y by itself. So to get y by itself, to get rid of the natural log, I multiply by its inverse. So basically, I'm taking e to the natural log of y equal to e to the 1/3 x cubed plus c. All right, that's essentially what you're doing. I'll probably skip the step on the left side. I probably won't write that every time, but I just want to show you guys like how I'm getting there. So hopefully you've had experience solving for logarithms where that's not anything too foreign to you. If it is, let me know in the chat and we can talk about it a little bit more. But e raised to the natural log, since they're inverses of one another, they're going to cancel out. You're just left with whatever's inside that natural log. So that becomes y equal to 1/3 x cubed plus c. Now, this is a step that's important because right now you guys are looking at this, you're probably like, oh, that's not so bad. Like that's an answer, right? Y is by itself. You're going to see an answer expressed in a different way, and here's how. I can keep going from here, and I can rewrite the right side as, instead of e to the 1/3 x cubed plus c, I can write it as e to the 1/3 x cubed times e to the c, using my rules of exponentials. Instead of a plus in the exponentials, I can split it up into two separate e's. Now look at this. E raised to the c power is just a constant. E to the c is just saying like 2.71 raised to some random value. That's going to just give us a number. What the number is, who knows, but it's going to be some number. So with that being said, we can change this entire term, e to the c, and just write just c. So y is equal to e to the 1/3 x cubed times c. This becomes your final answer. And this is how you'll see AP will address it, Khan Academy will address it, everyone, any kind of answers you ever see will write it like this. Or, like the book does, you might see y equals a e to the 1/3 x cubed. Where a equals some constant. So you guys are going to have to make your judgment just based off of what answers are given to you, whether it's given as an A or in a C or whatever. All you have to, the important thing is to understand is whatever that variable that's put there is just a constant. So you could see a K also, an A, a C, whatever it may be. Every book or activity you do might be a little different. Just what's important, just understand that all it is a number. It could be 0. Could be 17, could be negative 50. I don't know. It's just a constant. All right, and that's your final answer. So in the chat, let me know, guys. Feedback, good, bad, ugly. What do we think? Good? Okay. Cool. Okay. I'm going to do one more problem I'm going to give to you guys. I'll let you guys actually try to see if maybe you can solve it. But before I do that, because it's going to go to the end of the class, I want to say that the college board assignment, I haven't even assigned it yet, so I still have to assign it. But once it's assigned to you, it's not due tonight. It's going to be due Monday. So you guys will have all weekend. And then tomorrow's stream is going to be dedicated to that assignment. So I'll just be sitting here for an hour, and you guys can work on it. Ask me any questions you have, and we can go through problem by problem like we did last time, or people can do on their own, whatever you want to do. Just so you know, guys, though, you don't need to email me and say, oh, Mr. Harris, it's not updated, because I know I haven't posted it yet. So just be on the lookout for it. It's not due tomorrow. It's not due till Monday. So just wanted to address that now before I forget. Okay, practice. This will be the fourth example, and we'll end class with this one. So we're going to switch up the variable a little bit. So we're going to be du dt is equal to 2 plus 2u plus t plus tu. You know what? I changed my mind. I hate that. I don't want to write that. This is going to be a problem we're going to do. We're going to do, actually, let's do this. dy dx is equal to 2 plus dy plus x plus we'll do that, plus yx. Or xy, actually. However you want to write that, doesn't really matter. xy, yx, they're being multiplied. Let's just do that, because my t's and pluses are going to be way too similar. It's going to cause confusion. So let's just do dy and dx instead. So I want you guys to take like 5 minutes, try to solve that problem. If you get stuck, don't worry about it. When that clock hits 10:56, I will start going over it. So now that you guys have had a little bit of time to play with it, I do want to give you the first step. And then maybe you can go from here. So if you didn't notice, it's going to be hard to separate y's and x's and then the constant as well. So we have these situations. It's not necessarily right away easy to see how we're going to separate these. So what we want to do actually is we want to factor by using grouping. So when we factor, we get 2 times 1 plus y plus x times 1 plus y, which means that dy dx is going to be equal to 2 plus x times 1 plus y. All right, so now that's going to give us our variables separated a little bit. Now we can divide and multiply and so on and work from there. So I'm going to let you guys go from there, see what you can do. Okay, guys. So we got about 3 minutes left in class. Let's take a look at this. Hopefully you got at least a pretty good chunk of the problem through. Okay, so we're at this situation now. Now we can separate x and y. So I can rewrite the left side as dy divided by 1 plus y. And then the right side is 2 plus x dx. Okay, and then I can take the integral of both sides, and I get natural log of 1 plus y is equal to 2x plus 1 half x squared plus c. So the integral of 1 over 1 plus y is the natural log of 1 plus y. Integral of 2 is 2x. Integral of x is 1 half x squared, and then plus c. Okay, now the rest is algebra, with the caveat of that c. That changes things just a little bit. So I'm going to basically take e and make it my base of both sides of the equation. Okay, and when I do that to the left side, it cancels out the natural log to just give me 1 plus y. And then the right side turns into e to the 2x plus 1 half x squared plus c. So I'm going to do this last step just because we're running out of time. I'm going to subtract 1, and I'm going to rewrite the e, the exponential, as e to the 2x plus 1 half x squared times e to the c, all minus 1. Like I said before, that term right there is just a constant anyways. So my final answer can be rewritten as c, a constant, times 2x plus 1 half x squared minus 1. All right, and that would be your final answer. So I know I went through that kind of quick. If you guys have any questions, I got about 2 minutes. Please ask them in the chat. Let me know. I'm good. This stuff isn't too hard. All right, good, Brandon. Sounds good. Brandon said I'm good with this. Peyton said good. Emma's thumbs up. All right, very good. Katie says all good. No, Peyton, the College Board is not open. I will open it probably sometime this afternoon, like late afternoon. Jasmine says good. All right, very good. Well, AB guys, hope you have a great rest of your day. I will be here tomorrow. If you need anything, I'll have my office hours later, so stop on in. See you guys later. Algebra 2 people, welcome, welcome. Guess I'll switch over to my face now. You have a good day too, Haber. Aw, thank you, Stacklin. I appreciate that. Have a good day, Stacklin. Morning, Jaden. Welcome back. Algebra 2, here we come. Ugh. Yeah, sure, Jaden. What topic do you want to do? Sorry, Jaden, you gotta pick another one. That is not my forte. I will not do well with that topic. Mr. Harris isn't much of a Disney guy. Oh, Jaden, you selling cookies? Look at that. Movies. All right, I can do movies. Um. Hmm. All right. There's your hangman today. You guys might be able to get this without even guessing any letters. Oh, you were selling cookies and you bought some. Gotcha. Good business venture, Sierra. Smart thinking. Tennis. Yep. Up. That was the answer. Tannis is 2 wins. Tannis has 2 wins on the year. That's impressive. Tannis is leading the scoreboard in the Algebra 2 annual Hangman game. Sierra, don't give him your number here. Just you can find another way to get a hold of him, but no need to put your cell phone number here. Oh, you did it anyways. Try to keep any sort of information off the chat, guys, if you can. Only because this is a public, I guess, stream. So I don't want anyone seeing anything that they don't want to see. So sorry, Sierra. All right, that's good, Jade. No problem. So, guys, I got to talk to you first. So I got important announcements to make first, and then we will get into today's lesson. So, let me get started because it's 11:06. I talked to you guys yesterday about kind of the situation in terms of like how different teachers are coping with this whole situation, how we're doing our lessons, all that good stuff. And a lot of questions were raised. And so what we're going to do now is I'm going to just talk about what I guess the plan is moving forward, because I think some answers were given and some solutions were actually come to. So I know we had a good talk yesterday from a lot of you guys, and you guys gave me some good feedback and said you kind of liked what we're doing. We're going to have to switch it up a little bit just because that's what I'm told to do. So here's the idea. Here's the plan. The rest of the week, we're going to keep doing what we're doing. So I'll still have my stream today. We'll do a little quick hour tomorrow, and we'll be done for the week. from here on out, what's going to happen is math is going to be dedicated to 2 days a week. So math is going to be Monday and Wednesday. And your other subjects, so I think math and science are Monday, Wednesday. Every other subject is Tuesday, Thursday. Friday is like an overall review day. All right, that's the outline. So how I'm going to do this is it's going to be basically we'll do lessons Monday and Wednesday. So I'm going to still teach you like some new stuff. I'm not just going to not teach you anything. I still want to give you lessons on some new topics, some new subjects. Just because I think my goal here is to prepare you for your next class, right? If you guys were graduating, never taking a math class again, and maybe things are a little different. But a lot of you guys are taking pre-calc next year. And even if you're not, if you're taking any sort of math class, this is just going to be a good way to keep you guys, your math brains fresh and just keep you busy and, working on math. So the prediction is this could be a long-term, we know this could be a long-term absence from school. That would stink, but I think a lot of people, you've probably heard it before, a lot of people are saying, yeah, I don't think this is going to be going on, or I think this was going to last quite a bit of time, like potentially to the end of the school year. So we gotta prepare for that, and in order to prepare for that, I think as a whole, Vermilion High School decided to maybe reroute a little bit our mindsets on how we're handling teaching. And part of that is not overworking you guys. That's kind of the main idea. I guess there's been a lot of feedback, like people are scrambling all the time, too many assignments are given, stressing people out, kids aren't able to cope with it, all that good stuff. So with that being said, we're making an adjustment, and I'm not the only teacher. This is going to be, every teacher's supposed to be doing this. So Monday and Wednesday will be math centered with science, obviously, but you'll do science however your teacher wants to do it. But for me, I'll do my streams still on Monday and Wednesday. I don't know what times I'm going to make the streams. I don't know how long I'm going to make the streams yet. Haven't decided any of that. I think I'm just going to stick to an hour. Because if to learn a topic, I think an hour is plenty enough time to get through what I want to get through. So we'll probably still stick to an hour from 11 to 12, the usual stuff, except we'll only do a Monday and Wednesday, which means Tuesday and Thursday you guys will have completely off. The expectation too is that you don't have any work Tuesday and Thursdays in math. The idea is you're supposed to only be working on those subjects dedicated to Tuesday and Thursday. Meaning Monday I'll give you a lesson and I'll give you an assignment to do that'll be due Wednesday. Whether that's Alex, Khan Academy, notebook or bookwork, I don't know. Whatever it is. But it'll be due Wednesday. So you'll have Monday, you'll have after my lecture, all of Monday, all of Tuesday, even though you're not supposed to be working on Tuesday, if you procrastinated, you can do it Tuesday. It's not going to be long assignments because we're supposed to keep them under 30 minutes. So whatever we got to do to keep our assignments under 30 minutes, that's what we're supposed to be giving. Wednesday, I'll be teaching you another thing, so you'll learn a new topic. I'll give you an assignment for that topic, and that'll be due Friday. Friday will be dedicated just to review what we did Wednesday. And that's it. That'll be the week. So you guys will see my schedule will change quite a bit. Mainly just Tuesdays and Thursdays are going to be completely open. So there will be no stream whatsoever. So any questions you guys have on any of that? Comments, concerns? As always, I'll still be posting calendars, so everything that is due, everything that is expected of you will all be posted, so you won't be left in the dark with anything. We're just going to be cutting down a little bit on the number of assignments and the lessons. Okay. I'm not seeing anything in the chat, so I'm assuming we are good then. All right, so what I want you guys to do is go to page 492 in your books. That's where we're going to start today, page 492. Yeah, Sarah, I agree. I think that's the intention. Um, I get that. I get it. Yeah, it makes sense. It stinks a little bit, especially this ends up being like a long-term situation where we're out of school for the rest of the year. It's gonna inhibit a lot of your learning, but we've made pretty good progress in Algebra 2. And at the end of the day, more importantly is your health and your mental state. So, you know, whatever we got to do to get all of you guys, making sure everyone's in the right mindset and everything. So, I agree. I think this will be good. Just keep an eye on the calendar. Okay, so page 492. Guess I don't need my calculus book anymore. All right, so I guess I can switch over to this screen so you guys can see both. Okay, so we're going to be learning about common logarithms. So 7.6 common logarithms. You guys can put that down in your notes. That's what we'll be starting with today. 7.6 common logarithms. All right, so you can see at the top here, this Y. I always like to read these. I just think it's kind of interesting stuff usually. So it says seismologists use the Richter scale to measure the strength of or magnitude of earthquakes. The magnitude of an earthquake is determined using the logarithm of the amplitude of waves recorded by the seismographs. The logarithmic scale used by the Richter scale is based on the powers of 10. For example, a magnitude 6.4 earthquake can be represented by 6.4 equals log base 10 of x. Okay, so they use this idea of a log base 10, and you guys might have already been seeing this quite a bit or catching on to this. Okay, you notice by now that we have a lot of log bases. So we have these log bases that are varying. So it could be 6, could be 5, could be 4, you know, a lot of different ones. But what we've seen a lot of is 10. And maybe you guys have asked yourself, why 10? Why have we seen 10 so much? And that's what this lesson is going to kind of talk about. So we're going to talk about our common logarithm, which is base 10. So you can see all these different kinds of Richter. So the higher the Richter, the bigger the earthquake, basically. The smaller the Richter, the smaller. So a lot of times, like we can, like these little ones here, if you guys get an earthquake that measures like a 1 or a 2 or a 3 even, I don't even know if you feel any of these. Like these earthquakes might not even be felt by humans, but they still register in the Richter scale. When it gets like to 5, 6, 7, 8, then it's real. Then you got an issue on your hands, right? All right, so this is how they're evaluated. We're scrolling down a little bit where it says 1, common logarithms. You have seen that the base 10 logarithm function, y equals log base 10 of x, is used in many applications, which is true. Base 10 logarithms are called common logarithms. Common logarithms are usually written written without the subscript. So this is really important. You guys don't need to write this down. But I just want you to understand this. And I talked about this yesterday, if you watched the video or if you were in my stream. I talked about natural log at the end of class. And the natural log was a special kind of log with a special kind of base. We haven't talked about it yet in detail. But the idea is that we don't write the base. People in math are generally lazy, to be perfectly honest. So whenever we don't have to write like extra stuff, we don't write it. So at some point it was decided that this log, you're going to have a common base or a common log of 10. So we don't have to keep writing the 10 over and over. If you guys ever see this, if you ever just see log of x, you have to assume the base is 10. So from here on out, from here until the end of math, to the end of your math days, if you ever see a logarithm with no base, that doesn't mean it doesn't have a base, or like the base is 0. It means that the base is 10. They were just too lazy to write 10. Is basically how it boils down to. Okay, so I'm going to have a hard time doing this, but we have Desmos and we have access to Desmos. So if you guys look at this, like if I go to Desmos, a lot of you guys have scientific calculators and you'll see that button that says log. If you have log base 10, you don't have to put the base. You can just put log and then it already knows it's base 10. And I think Desmos might as well. Yeah. So like if I were to find log base, well, let me actually do the example they do. Log base 5. In Desmos, you don't have to put log base 10, so I don't have to do this anymore. All right? I can just do log 10, or sorry, log 5, and then it gives me the answer. Okay, so just so you guys know, I can't like show you a scientific calculator because I don't have one. But if you have a scientific calculator, you guys can see there's a log button, same idea. Just press log and then the number, press equals, and bam, it gives you the answer. Not too worried about your ability to put something in a calculator, but I just want to talk about the fact that's what we call a common logarithm. All right. At the bottom of the page, it says the common logarithms of numbers that differ by integral powers of 10 are closely related. Remember that a logarithm is an exponent. For example, in the equation y equals log x, y is the power to which 10 is raised to obtain the value of x. All right, so we've seen this before, right? We can write by the definition of logarithm, we can rewrite this as 10 to the y equals x. So guys, just as a reminder, we're good with this, I feel like, if we have a base. So we've learned if like this base right down here was like 6, we would know that x would be equal to 6 to the y. Same idea. We're using the exact same rule, except we just have to understand the fact that the log that doesn't have a base is always 10. So you guys can see for all of these, it ends up being 10 raised to a power. Okay? So again, just keep in mind, logs without bases are log bases of 10. Actually, don't know if I wanted to do that. Hold on. Don't think I did. Okay. All right, so let's look at the top of 493. All right, it says common logarithms are used in the measurement of sound. So soft recorded music is about 36 decibels. All right, so that's how common logarithms are used. Looking at this real world example, it says the loudness L in decibels of a sound is L equals 10 log of I over M, where I is the intensity of the sound and M is the minimum intensity of sound detectable by the human ear. So you guys know, like with dogs, they can hear certain stuff that we can't. Our ears can only detect certain sounds. Okay, so residents living several miles from a concert venue can hear the music at an intensity of 66.6 decibels. How many times the minimum intensity of sound detectable by a human ear was this sound, if M is defined to be 1? Okay, so let's just look at this then. So let me go down to my screen. So again, this is real world example 2. the question with decibels and whatnot. So I'm given the fact that L equals 10 times log of I divided by M. That's what's given to me in the actual question. The question wants to know how many times the minimum intensity, where I is the intensity, so we're looking for I, if M is 1. So I can replace M as 1. So I just get L equals 10 log of I. But the loudness L I was given. So it tells me that I'm given that the music is an intensity of 66.6. So 66.6 is my loudness. So I'm left with 66.6 equals 10 log of I. Okay, now the rest is algebra, and this is stuff we've been working on quite a bit in the last week. So I want to solve for I. That's the intensity that these people are detecting. So to solve for I, let me first divide by 10. So 66.6 divided by 10 gives me 6.6. So I have 6.6 equals log of I. And this is kind of where the new stuff kicks in. So if I'm looking for I can rewrite this if I want, if it helps you, as log base 10. Because a log without a base is always log base 10. So given this equation, the definition of a log says that this 10 can become my base on the other side of the equation. I raise that other side of the equation into the exponent and set it equal to whatever's left over. So my answer ends up being 4,570,882 times as much. Okay, so that's a little real-world example of sound and using logarithms. Again, remember the log base was 10. Okay, guys, let me get some comments in the chat. Let me see how you're doing, how we feel about this. Why did it go from 66.6 to 6.6? Sarah, I did that because I divided by 10. So you can see in my example, this is 10 times log I. So if you divide, get rid of that 10, divide by it, you get 6.6. I don't know where that came from. That's funny, Tanis. All right, I'm assuming we're good then. Okay, so I got a really, really important example to go over next. Okay, so focus in here. So let's look down below this real-world example. It says if both sides of an exponential equation cannot easily be written as powers of the same base, you can solve by taking a logarithm. All right, so you guys might remember, what is this, example 3? You guys might remember before. Okay, let me just give you a quick example. we had something like 2 to the x equals to 4. All right, this is like a really, sorry, let me not put example 3. This is just review. You don't have to write this in your notes, just reminding you. Okay, you had something like this. Clearly really easy to solve. All right, but if I had thought of a harder problem, it wouldn't have been as easy. And what we did is we said, okay, well, let's rewrite so both sides of the equation have the same base. Right, so we rewrote 2 to the x, we kept that the same, but we rewrote 4 as 2 squared. Now that they have the same base, 2 and 2, we just set the exponents equal to each other. So we got x equals 2. Right, not so bad. Okay, that's something we did, that's just review. But now we're saying, let's check this out. What about if we have something like this? 4x equals 19. If we want to solve 4x equals 19, how would we do that? Because 19 can't be split up. 19 is a prime number. There is no common base for 19, unless it actually was 19, which we can't rewrite 4 with the base of 19. So how do we solve this? That's the question. And this is a really, really, really important topic, especially for those of you moving on in math. How do we solve this? So what we can actually do is called the property of equality for logarithmic functions. The property is saying this, okay? Remember, guys, in these problems, when we're solving for logarithms, what we were looking for was to have the logs on either side be the exact same, and then we just set whatever's inside the log equal to one another. Kind of a similar idea. What we can do is think of it as taking the log of both sides. We're taking the log of both sides of the equation. So I'm taking log of 4 to the x equal to log of 19. Right? This is equal to this. Really important to note that that first line is equal to that second line. All we did was add a log to both sides. And we might be wondering, why, Mr. Harris, would we do that? Well, we did that because now I can actually rewrite some things. So like this left side, I can use my power property. My power property says that I can take my exponent and throw it out in front of the log. So I'm left with x log of 4 is equal to log of 19. Again, you start off by taking the log of both sides, use your property of logarithms, or your power property to take the x out in front, and now I'm left with this. Okay, so now how do I solve for x? Well, logs are just values. So think of this as just like a constant. Let's think of log of 4 just as like the number 3. This was just like saying 3x equals log of 19. So if that were the case, you would just divide by 3 to get x by itself. Same idea. We divide the constant, or the coefficient I should say, we divide the coefficient out. So I divide everything by log 4 on both sides. So I'm left with x equals log of 19 divided by log of 4. Okay, and if I go to my Desmos, all I got to do is just plug that into my calculator, and I get x is approximately 2.124. As my answer. And that's the problem. Any questions on that? Very, very useful idea right there. All right, Aiden says nope. Anyone else have any input? We're going to go over another example, but anyone else have like a question on what I did? Okay, I'm taking that as a no. All right, let's do a practice problem. So let's do guided practice 3A. So I want you guys to try it. Give you like 5 minutes, man, probably less. Maybe 3 minutes, 4 minutes. See how you're doing. And then go ahead and put that answer in the chat when you get it. Looks like my stream is kind of buffering a little bit, guys. Hopefully you can still hear me and see what's going on. I don't know what's going on though.